Hello, thank you for joining and welcome to what I know you guys have already been experiencing, the first remote conference. I'm Logan Campbell. I am the presenter today. I'm the founder and CEO of Aerotas, and I will get into all of that in a second. But thank you all for joining. With me here is the moderator of our panel today, Trey Swan. So I will let him go through some introductions and a handful of the required readings and stuff that you've probably already heard before, but here it is anyway. Trey.
Yeah, thank you very much for joining the virtual conference. Today we're going to be talking about drones, and so if the goal is to produce a topographic or a planimetric survey with a drone, then you've come to the right place. Today's session will be why flight operations matter. So these are going to be best practices for collecting high quality survey data with a drone, and it's going to be presented by Logan Campbell, who you just met. Logan is the founder and CEO of Aerotas. He is an ASPRS certified photogrammetrist. He started working with surveyors back in 2014, and heck, he's really kind of written the book on using drones to collect survey grade data. Aerotas is a drone data processing company and freely shares guides, instructions, checklists, and best practices developed with thousands of surveyors over tens of thousands of drone survey projects. And Logan is here today to share everything that he's learned along the way with you. And really the goal is to impart all of this knowledge so that you can go and build this proficiency in-house if you want to. Information regarding our speaker and handout materials are available through the conference app portal. In the conference app, you will also find information regarding our exhibitors and sponsors, notifications, as well as a chat feature that will allow you to network with other attendees. So if you have not already taken a moment to explore the conference app and book a meeting with exhibitors, we definitely encourage you to do so. Today, during this presentation, we're going to be using the Q&A panel for you to ask questions. So take a moment, if you could, and find that Q&A button and open that panel. So it's going to be a little bit different depending on what you're using. So the location of that button might be different depending, but typically it's found on the toolbar at the bottom of your screen. So for me, it's at the bottom. It says Q&A, it's right next to participants. And if you pop that open, you'll be able to ask questions as we go. So as the moderator, it's going to be my job to kind of monitor this Q&A panel, and I'll make sure that Logan answers your questions. We definitely want this to be interactive, so please don't be shy. The more questions, the better. So if you ask a question, I will be playing the role of cutting Logan off, making sure that your question gets asked and answered. So please, the more questions, the better. And with that, I will turn it over to our speaker, Logan Campbell.
All right. Thank you very much, Trey. I appreciate it. And yeah, as Trey said, I really can't stress enough, I really like questions. For any of you that have seen me talk, this might actually be a little bit of a different experience for me because I'm so used to interacting with people. A lot of these topics when it comes to drone surveying change a lot. This drone surveying is not a technology that has decades of history and refinement around it. There are new workflows, new procedures that come out every week, every month, every year for sure. And so a lot of times there are questions about what we do, why we do it, and maybe why things are different from last year or 5 years ago or whatever. So please do use that Q&A button a lot. I will be there to answer things. So with that, let's actually dive straight into it. What are our objectives today? We're going to cover a couple of things in the next 2 hours, all related to what we call flight operations. And that means we're going to cover everything from drone hardware, what we actually mean by flight operations. We're going to go over mission planning for drones, planning for control points, ground control points, checkpoints, field data collection. We'll touch on a little of the legality issues with some of the laws with flight operations and that sort of thing. And basically everything that goes from I start with nothing all the way to now you have a whole bunch of photos and then you do everything else in the office. As a little preview as well, at 3 o'clock, at 3 o'clock, I will be giving another presentation that's all on the office processing side of the workflow. But it is very, very good to start here. These are the flight operations part is the foundation of any drone data processing or any drone program at all for surveying, because this is where you get the raw material that then turns into actually good accuracy. Another thing that you're going to hear me talk about a lot is saving time and money. Now the reason I bring this up right at the beginning is because our perspective on a drone survey program is that it should save you time and money. It should be a business. it shouldn't be a research project. And in fact, some of the things that I'm going to talk about are kind of the antithesis of a research project. Because when you're working in a research project, you might have an objective to get the highest accuracy possible, and it doesn't matter if it takes you 300 man-hours and a couple of weeks to do it. And we kind of say that's not how it ought to work for a business. This shouldn't be a research project. This should be a business. This should be about saving you time, money, get better deliverables, get all kinds of benefits out of your drone program, and make sure that it's not a research project. So a brief little bit about us. Trey kind of gave you the quick intro beforehand. We do drone data processing for land surveyors across the entire United States. And we've been doing it since about 2014, which, while in the land of surveying, that makes us a relatively new company. In the land of drones, that makes us kind of the old guys at this point. So it's fun to still be doing this and kind of be among the longest lasting drone data processing companies out there. But we focus on human-in-the-loop drone data processing specifically for surveyors and engineers, and we'll touch on that throughout what I go through. In fact, when I talk about flight operations, everything that you're about to hear has come from our experience, from the thousands of surveyors that we've worked with, tens of thousands of projects that we've done. We have, a wealth of experience that could never be accomplished by any one single company without the work of lots of different things to know, okay, what works in what scenarios? What are the differences? What are some of the best practices that'll get you there 99% of the time? But that's what we do. We do drone data processing, and these are all of the things that we have learned the hard way. About me, I am the CEO and lead photogrammetrist at Aerotas. I actually have a formal education background in finance and statistics, which then parlayed pretty well into photogrammetry. So I've worked in photogrammetry and surveying and financial analysis, and I am a ASPRS certified mapping scientist. ASPRS, for those that aren't familiar, is the American Society for Photogrammetry and Remote Sensing, a fantastic organization that I will talk about a lot in my second session on data processing. But they're the ones that train and educate and do everything with photogrammetry to get good data. So moving on, a good drone program. There are a few things that every good drone program should do. The first thing, and like I said, it's all about saving time and money. It's all about making this a good business decision. The first is it should increase your flexibility as a business. It should allow you to do new projects that maybe you couldn't do before, covering more land, reaching unstable areas, doing a lot more projects. Serve as a force multiplier because it saves you a whole bunch of time in the field. That means a crew can do in half a day what it used to take 2 days to do in the field for topo data, and scale up and down based on need. In fact, that these days is one of the biggest benefits in this kind of crazy world that we live in, with some projects getting canceled, new ones coming up. Flexibility is a really, really important thing. So being able to start new projects, finish them, run through them quickly, and then kind of scale back down is pretty important with this. Should also save time and money. Like I said, less time and manpower in the field and reduce overall costs. That's another thing you'll hear me, a theme throughout all of this is I will talk about costs and time and money with all of this, because all of my recommendations are not worth anything if I say, hey, go out and buy this $500,000 drone. It's fantastic. It gets great data. Because, well, we've seen data from $500,000 drones, and yeah, they do get really good data, but you're never going to make money off of a $500,000 drone. At least, not unless you're in the military. And lastly, having a drone program really ought to get you better deliverables than before. It should have the same accuracy as traditional surveys. You shouldn't have to give up accuracy at all in order to do this. But it can get you up-to-date, higher quality imagery and a perfect record of site conditions. Our data has been used in disputes resolution all the time because you do have this fantastic 3D photographic representation of exactly how a site was when you flew it, what work was done, what work wasn't. It's just it's a higher quality deliverable than you get without actually doing this or just by using satellite maps or anything like that. So that's what a good drone program should do. But unfortunately, there are a lot of pitfalls that people do, that people fall for, that make it so that these drone programs really just wind up not being good. First off, people often use the wrong tool for the job. Sometimes the drone is not always the right tool for the job. Not everything can be done with a drone. A drone is not going to be as accurate as a total station. Just as a total station or a GPS unit, you know, there are benefits and trade-offs to each one of those. The same thing with a drone or a laser scanner or even an airplane with traditional manned photogrammetry. There are trade-offs with all of these things. So make sure that you pick the right tool for the job. Part of flight planning and part of this flight operations is how do you pick the right tool for the job, and I'll cover that in just a second. Another thing, don't overspend on gear you don't need. Drones are very flashy. They're kind of the new technology on the block, but thankfully over the last couple of years, a lot of that appeal, the shininess has kind of worn off because people are realizing that buying the coolest looking drone doesn't mean that it's the best functioning drone. There are drones out there that I like to call kind of the Ferraris of the drone world, which, yeah, it's fantastic, it's cool, everyone wants to have one, but no surveyor uses a Ferrari for their work truck. You use a truck. Same thing with drones. You kind of want the workhorse, the truck. Don't buy the Ferrari of drones because you're not going to make any money on it. And we've seen people fall for these pitfalls. Another thing, don't spend too much time in the office. Drones have this huge promise of saving time in the field, and that's absolutely true. They save enormous amounts of time in the field. But a lot of people get caught up by saving 10 hours in the field and then spending 15 hours on data processing trying to solve it all. So make sure that you actually think throughout the whole process. You think about how much office time you're going to spend, manage that to make sure that you don't spend too much time. And lastly, I've said this before, don't treat this like a research project. A good drone program is boring. Very, very ridiculously boring. In fact, I remember one of the earliest drone flights I did for a survey company. I was showing off, you know, here's what a drone, this was way early on. And a surveyor brought his whole family, including his kids, his like 13-year-old kids, to come see the drone. And I was just like, buddy, you're going to be so disappointed by this. Because he sits the drone, it's like, all right, it's going to fly. This will be so cool. And you just push a go button on an autopilot, and then it just kind of goes up until you can't really see it. It's extraordinarily uneventful. And when it came back, it has all of this valuable data on a memory card. It's boring, and it's super valuable for surveyors. That's what we want. That's what we love now that the hype is dying down, that it's just getting boring. It's not a research project. It's not some crazy new sci-fi technology. It's a tool. We treat these things as tools. We use them like tools, and they treat us well. All right, so let's talk about the drone surveying journey next. To me, this is the path that basically every drone program takes, more or less. It's sometimes a little different for different people, but everyone kind of goes on the same drone surveying journey as they learn the different things that you can do with drones, as they get more comfortable with drones, utilizing them as part of the surveying workflow. Most people start with just basic photos and videos. You buy a drone, heck, sometimes you can buy a drone at Walmart for 30 bucks, and you can actually go up and just take some photos and videos. It's actually really cool, super easy, great stuff, good for site documentation. A lot of people have bought a drone just to like take pictures because it's a really easy way to take pictures all around a site, and hey, it's kind of fun too. So lots of people start with that. Next thing is ortho photos. You start using an autopilot, the drone flies them automatically, takes a bunch of photos, you stitch them all together into a single map, a single photograph. That's pretty great. Not really good enough for accurate for measurements. It might be off by a couple of feet here, a couple of feet there, but it's a good ortho photo. It's a good way to see an entire site all together. Then you start getting really good with photogrammetry, integrating your ground control points, maybe integrating RTK and PPK data with the drone itself, processing all of that together to get very high accuracy and high precision ortho photos. Now, all of a sudden, these are actually good enough to make measurements with so that you can measure and extract data from the site and actually use it on a plat. Next up, people start working in 3D data. You start with that ortho photo, which is kind of 2D data. And then people start going into the surface models, the point clouds. You're extracting elevation data, topo data. Maybe you're starting to draw some contours and basic things like that. Moving forward, you start then integrating all of that into CAD. Instead of just having maybe these automated contours that go around trees and buildings, you start cleaning it up, getting it into CAD, integrating it with your other field shots to get cleaner data. And then you start putting that all together into your final survey deliverables, which means that you're integrating the ortho photo, your ground data, any historical or records data together and putting it together. And lastly, combining all of that into an integrated workflow so that it is easy, repeatable, and just kind of the standard thing that you do, that your whole crew, from when you start a project, you just know this is how the drone's going to get integrated to it. So it just It runs quick, smooth, and like I said a million times already, it saves you time and money. And flight operations, what I'm talking about for most of the time today, is really the foundation with this. Flight operations, just making sure that you get the right data, is the foundation that allows you to build this whole pyramid and go on this journey to get super high quality, reliable, repeatable data out of your drone every single time you use it. So next up, we talked about flight operations and mission planning. I use those terms interchangeably a fair amount. This is what the process looks like for every single drone project. It starts with mission planning. That's what I'm talking about now. Flight operations, mission planning, where do you fly, how high do you fly, how many ground control points do you set, should you even use the drone? You start with that, you move on to data collection, you go out in the field, you fly the drone, it's really easy to fly a drone. Then there's the processing side of things. The photogrammetry is the first step of processing. That's when you take the photos, stitch them together. Then you draft your line work, you draw your planimetrics, your 3D data. This looks like my video froze for a second. Let me fix that. Draft your line work, create a nice clean surface, create a tin, extract your topo points, and then finish everything in CAD, bringing it all together actually in Civil 3D or Carlson or whatever survey suite you may use to actually get that final survey deliverable. So my first session here, all about mission planning and data collection. My second session, all about photogrammetry, line work drafting, CAD finishing, things like that. So next up, this is what a typical aerial survey ought to look like. This is from our partners at Arizona Surveying. That was a finished deliverable that was done integrating drone data. And one of the things that I actually really like about this survey is when I look at it, I say, okay, what was taken with the drone and what was done on the ground? And the answer is, you have absolutely no idea. And that's okay, because ultimately what clients want is a survey that they are hiring you to create. They do not care what method you use most of the time, some of them do, but usually they don't ask for a drone survey, they ask for a survey. They ask for an ALTA, they ask for a topo map, a tin surface, contours. So being able to utilize all of that data together, pick the right tool for the job, use a number of sources, and create a survey, a final survey deliverable from the data, that's the goal, that's what everything should look like.
Logan, we've actually got a question.
Sure.
So one of the questions is, what determines the number of targets?
That is a great question, and I'm going to put a hold on that for just a second because I've got a whole couple of slides coming up on that for the number of targets. But the real short answer is, it depends on a couple of factors such as flight altitude, area, and whether you're using RTK or PPK. Those are going to be the three main factors, but we'll cover that in a lot more detail. There's some slides with some tables that will really help you out there. First, one of the first questions that a lot of people ask is, what is the latest in drone technology? What drone should I actually be using? And let's actually just jump right in and cover some of the different drones that are out there. So generally speaking, there are three categories of drone cameras that can be used that are, all have their kind of slight different trade-offs, but more or less there's the drone-specific camera. And this is the camera that's used on the DJI Phantom 4, the Phantom 4 RTK, or a unique H520, the M200, M300 series. Those all have built-in integrated cameras to them. Those cameras are really great. They typically cost, they start at about $3,000. Depending on what you go with the Phantom 4 RTK, you're looking at $10,000 to $15,000 all in. You get into the DJI M200, 300 series, you're looking in the $20,000 to $30,000 range. Next up, you can get these large independent cameras, the Sony A7R, ones that are strapped onto these bigger multi-rotors, much more complex combinations. Some of the DJI drones can handle those as well. They are often a lot more expensive. Typically, from our experience, actually, the way technology has been moving, this large independent camera that we've talked about is a very, very small portion of the market anymore. People have realized that integrating a lot of diverse pieces of hardware technology, including these large independent cameras, doesn't actually work too well. It's not very reliable. You buy these big cameras, and more often than not, you fly it, and it just doesn't get the data that you need for one reason or another. It's a really complex stack. And then the last thing, so that large independent camera is really a very, very small part of the market. We wouldn't recommend it. Very few people use them anymore. But the last one is LiDAR. LiDAR is a very, very interesting technology that is getting a lot of traction right now about aerial drone-based LiDAR. And we've seen a handful of LiDAR data sets ourselves. We've worked with some of them with some of our clients. And I'll give you the short answer is it's great data, and it's absolutely obscenely expensive still to be able to get that data. So a couple of thoughts on LiDAR actually first. First off, like I mentioned, I should point out, this is very specifically drone collected LiDAR in the current technological landscape. The data quality is pretty good if you spend enough money. There are cheap LiDAR systems out there, and a cheap LiDAR system is on the order of like $30,000 to $50,000, and the data on those is really quite awful. If you get a good LiDAR system, some of the Regal Minivux-based systems, those are $100,000 plus all in, usually quite a bit on the plus side, and the data quality is pretty good because it can get a couple of tenths vertical accuracy after accounting for all of the noise that's in there. But ultimately, it doesn't live up to all of the hype. Vegetation penetration is the #1 hype about LiDAR systems, that you fly the drone, you can fly it over a total forest and get a perfect ground surface. And it's actually not that great. Also, accuracy is typically about 2 to 3 tenths in real world conditions. 2 to 3 tenths is of course great for a lot of large scale vegetated topos, but if you're doing hardscape, sometimes 2 to 3 tenths really isn't what you need. And lastly, flight times are quite short on it still. It's a big, heavy system, has a lot of battery, has to be flown on a big, heavy drone that needs a lot more batteries. And so flight times are really short. It makes these things less practical if you're doing, 50, 100, 200, 300 acres. So that makes it a little tricky. And lastly, the real killer for LiDAR, in our opinion, is not the data. Everything above, like I said, big quality is pretty good, not perfect. It doesn't live up to all the hype. That's not a killer at all for it, because there are ways to manage all of that appropriately. The real problem is that a return on investment with this is nearly impossible. It costs hundreds of thousands of dollars, requires extraordinarily highly trained operators with a lot of experience. And then I know everyone, you don't want to take a kid who's first day on the job surveying and then give him a $150,000 drone and hope that he doesn't crash it into a tree. Your insurance company isn't going to be happy about that. And also processing LiDAR data is very, very expensive too. I've said that before, always think about the data processing side of things, think about your office time. Processing LiDAR data takes a lot of time. As anyone who's worked with LiDAR-based point clouds, I'm sure knows, it's expensive and it's hard to use.
Hey, Logan, we got a question. This is about Homeland security and drones. So are there UAS that meets Homeland security requirements?
Yes, that's a great question, and there are. DHS, as many people have probably seen, is not allowed to use DJI drones, and there are a handful of other companies and government agencies that are saying don't use DJI, and it's starting to bleed out that everyone's saying don't use DJI if it's a government-related project, things like that. And there are a handful of different options, so that vary based on kind of the project, the complexity, things like that. DJI is a Chinese company. It is made in China. They have some data quality things that, make people a little concerning, which makes sense. So the government has more or less banned them. Problem is, they are far and away the market leader with this technology right now. So there are always going to be trade-offs when you move away from DJI. Now, there are a couple of options once you go there, depending on how strict the requirements are. A lot of this technology is still made in China. So even if you buy a unique H520 as a competitor, it still is going to be more expensive and not quite as good as the DJI drone, and still made in China. Some of the other options that are out there, though, Intel has another drone called the Falcon 8, which, like other things, it's going to be way more expensive and typically much more complicated to use, but can get you very high quality data. That's going to be on the order of $20,000, $30,000, something like that. I believe that one's manufactured in Germany by an Intel company. There is the Lockheed Martin actually makes a drone, the Indago, I'm not sure how it's pronounced. It's basically a military spec multi-rotor. Again, very complicated to use, costs close to $100,000, I think, for that, and that isn't going to get you as good data as a Phantom 4 RTK still. And the other very common one that's actually really good as well is the SenseFly EB. It's a fixed wing drone that can cover a lot more ground, RTK enabled, great drone, market leader in fixed wing technology, absolutely. I believe that is manufactured in Switzerland and sold and distributed all in the United States and qualifies for that. So I hope that, that answers your question. So there are options. There's no perfect Phantom 4 RTK substitute. We love that drone. It's the best drone on the market right now, but there is no perfect substitute for that, at least not yet. Fingers crossed. Hopefully we've got some domestic hardware manufacturers that'll step up and make something of high quality. Moving on, we're actually talking about some of the different airframe options here. I mentioned a lot of this already. The small multi-rotors start with the DJI Phantom 4 Pro and the Phantom 4 RTK we put in that one earlier. Those are absolutely fantastic, far and away the most common. They're really the workhorse drones of the drone surveying fleet. The Phantom 4 Pro starts at $1,500 for the hardware, so it's a really, really cheap investment, all things considered, to get started with, and gets very high quality data when you have good flight operations planning. The higher end of that is going to be the Phantom 4 RTK, which all in is about 10 grand. So obviously a little bit more expensive than that, but gets spectacular data quality, especially if you're doing large project sites. There are larger multi-rotors, the M200, M600, M300 series from DJI, that are a lot bigger, a lot heavier, and a lot more expensive. In our experience, for surveyors and engineers, they offer basically no appreciable benefit over the other one. The data quality is fine. With most of them, you can buy the wrong camera and then it won't be fine. But with most of them, the data quality is comparable. It doesn't get you any better data quality. Those are really targeted towards other applications. The M200 and M300 series, a lot of them are targeted towards like police and security things where you do need to have thermal cameras to spy or to capture people running around in the dark, or specialized cinematic cameras so that you can film a car chase in 8K video at 120 frames per second or whatever like that. But those sorts of cameras and sensors don't really have any benefit to the surveyor and engineer workflow. So if you have one, perfectly fine. You can get great data out of it. But from our experience, the Phantom 4 RTK is kind of the best one as far as the multi-rotors go. But then lastly is the fixed wing category. Like I said, the SenseFly EB is the market leader, the EBX. It is a spectacular drone. It's pretty expensive. Again, you're looking in the about $30,000 all in-ish range for an EB, but it can cover a huge amount of land, hundreds of acres per flight. So if you're regularly doing surveys on very large sites, the EB is fantastic. However, if you're not doing that very often and you want to do surveys on sites that are 1 acre, 5 acre, 10 acre, 20 acres, the multi-rotors make a heck of a lot more sense. They're much more versatile. But if you are doing those big sites, EB is spectacular.
Logan, real quick, question about battery life. So what determines the estimated battery life? Acreage to flight height ratio? Question mark. Yeah.
There are a lot of small things that make that change it up, but estimated battery life is generally measured in minutes, and because of just the aerodynamics of these, doesn't change a lot based off of flight height or anything like that. So real-world considerations, a Phantom 4 and all of the drone, really all of the multi-rotors, have a realistic battery life of 20 to 25 minutes. Sometimes they'll say, oh, it can fly for 35 minutes or 40 minutes, but that's until it literally runs out of batteries and crashes, so that's a terrible idea. But most of them are about 20 minutes no matter what. So the question that we often ask is not how long does it fly, because as a surveyor, you don't really care about how long it's in the air. You care about how much ground it can cover per battery. And I've got a table for that coming up that'll show you about how much ground you can cover per battery, because that's the real question that you really ought to care about. Short answer is the Phantoms, you can cover up to 50 or so acres of ground per 20-minute battery, whereas the fixed wings, you can cover a couple hundred acres per hour in a single battery. All right, so that's drones. But the other thing that is becoming more and more common to talk about, you've heard me mention the Phantom 4 RTK. It does not have the monopoly on RTK data in there, but because all of this new technology with drones is coming out and maturing, you now actually have options for what type of GNSS data processing you're using for the drone. First option is using no RTK whatsoever. That's what's been done for about 5 or 6 years now in drone photogrammetry. That means you're using only ground control points. The GPS that's on the drone is only accurate to plus or minus 10 feet maybe. Vertically, it's a little worse than that. But it's very affordable. It's a simple, highly reliable workflow. The drawbacks are lower accuracy, and you have to spend more time in the field to set more ground control points. This is the GNSS workflow that's used for the Phantom 4 Pro. Anyone that started drone surveying 3 or 4 years ago has experienced this workflow plenty. But now with the advent of putting RTK, PPK capable antennas, dual band GPS antennas on the drones, you now have different options for PPK, RTK with a local base, or RTK with some type of third-party base.
And Logan, actually
PPK,
tying into this,
yeah.
We have a question that relates to your table here. Can you purchase just the Phantom 4 RTK, and can you use that with Leica or a Trimble-based GPS station?
Yeah, so you can. You absolutely can. However, we don't recommend it. And the reason we don't recommend it is not because it doesn't work. It absolutely does work. There are workflows around that. There are technological setups, how you can connect the drone to your base station. You can do it separately and post-process everything together. There are 2 ways to do it actually with a third-party base. There's either the PPK workflow, which you see here, where you actually take all of the drone data and you post-process it with your third-party base station, or you can set it up via RTK. Now, there are drawbacks to both of these. With PPK, if you set it up with a third-party base station and post-process everything, it's very time-consuming because you have so many different files, you have to combine everything. So it's high-quality data, few GCPs, not a lot of field time, but it's the most time-consuming option. So RTK data with a third-party base, there are kind of 2 options there. You can either do it over a network connection. I know this one says NTRIP for network connection. But it actually kind of is the same with connecting connecting a third-party base station in real time to the drone. The big problem that we have with that workflow is that it's very error-prone in our experience. And not error in terms of like random stuff happens, like a satellite dish doesn't work or something. It's error-prone in that it's so complicated that if you don't click exactly the right settings, then it just doesn't link up, and you're not getting good quality data, and people get frustrated and think that it's not working. So it's not field reliable, at least not yet. So what I should point out is if you already have and already are using a third-party base with the DJI Phantom 4 RTK, and you are comfortable with that technological workflow, then keep doing it because you can get good data. However, we do not recommend it because it's so, you have to love troubleshooting technology problems. If you're a masochist for errors that don't tell you, like an error has occurred because there's an error. That's about all of the description you get when these workflows just don't quite, when you maybe type in a password wrong somewhere. Because of all of that, we actually really strongly recommend using a local base station, the one that DJI provides. It's certainly not the best base station in the world. In fact, I actually have one of these right here with me. The tripod that it comes with isn't great, but the most important thing about this is that it is a very, very reliable field workflow, and it provides very high quality data. So having this, it's actually not the way that DJI sells it. They really do not give you hardly any discount if you try and buy it without their base station. So we very much recommend using it. We found it to be the most accurate. We process all of these. We're familiar and comfortable with every single one of these workflows. But using that DJI base, in our experience, is the best because it's the most reliable field workflow. And that's where, again, it's really going to lean on what I've been saying that whole time. This isn't about the science fair project. The best accuracy with the best, like from the science fair project aspect, is totally use your Trimble, use your Leica base station, get a very complex RTK setup off of that. The Trimble and Leica base stations are way higher quality technology than this, but it's the science fair project workflow that just makes it impractical and makes it so that you wind up spending hours in the field just getting your data set up. And that's a pain in the butt. But if you like it, go for it. So that's our recommendation for the GNSS options. Really, like I said, the one that we see the most success for right now, the overall hardware setup, is this guy, the DJI Phantom 4 RTK. Looks like a Phantom, has its little dual band GNSS on top, 20 megapixel camera. This is just the most reliable, highest quality workhorse drone that is out there right now. You can reliably get a 1/10 of a foot accuracy. It just works, has flexible workflow options for RTK and PPK, get a whole bunch of batteries, a rugged field-proof case, your checklists, propellers, blah, blah, blah. These are the kits that are definitely the most reliable. This is whatever, when people are buying a drone, we recommend Phantom 4 RTK first. Only difference is if you only do very small sites, I'm talking 1, 2, 3 acre sites and nothing bigger than that ever, then you probably don't need the RTK. You're spending more money than you need to, but then again, it is, like I said, that future-proofs you and gets you everything much better. The other thing about our recommendation here for the Phantom 4 RTK is we actively don't recommend the M200 and M300 series. For anyone that's been shopping for drones with a dealer, they probably know that dealers are pushing the M200s and M300s all like crazy right now, saying it's the greatest thing since sliced bread. I'll tell you from the data side, it's exactly the same. Certainly it costs a lot more, and I'm sure the commissions are considerably higher, but maybe I'm just hypothesizing. Purely on the data side, Phantom 4 RTK is a great aircraft, great setup there. All right, so there's our hardware lineup. Let's keep going. Here's our general workflow again from drone to line work, and now we can dive into mission planning.
And Logan, you might be covering this in a second, but we do have a question about where in the Bay Area can you fly? And so are you going to be getting into airspace, controlled airspace and whatnot?
Sure am. Yep, I will get there very shortly, actually. So first, when I say mission planning, what is mission planning? Mission planning, I've talked about how important it is, blah, blah, blah. Mission planning is a series of kind of questions and tasks that are designed to figure out the best way to run the mission. This is everything before you put the drone in your truck and drive out. Starting to ask, is this a good site for drone photogrammetry? Is it legal to fly here? What altitude should I fly at? What's the appropriate overlap? How many ground control points? Where should I set them? How should I arrange it? And what data still needs to be done on the ground? Now, I don't want to intimidate you because this seems like a lot of questions, but after you do just a couple of drone surveying projects, this kind of just becomes second nature that you're familiar with this. But the key thing is to know that you have to ask the question to begin with. Why do you care about mission planning? Well, for starters, you save a ton of time in the field. If you plan it right, you set a lot fewer GCPs, you don't have to survey as much stuff on the ground, your flight times are shorter, and most crucially, no field revisits. Surveying, drone surveying, or traditionally on the ground, that's one of the biggest time killers is anytime you have to send a crew back out on site. That sucks. So being able to not have to do field revisits saves a ton of time and therefore saves a ton of money. But lastly, good mission planning saves office time too. If you don't plan your mission, you wind up spending, for every couple of minutes that you don't spend mission planning will cost you hours and hours and hours on the back end processing. You can get shorter processing time, better accuracy, fewer errors, and a simpler overall workflow with just a minute or two of mission planning, just even thinking about it before you just drive out on a job site and see what you can do. In fact, we actually have found that about 2/3 of the problems that we see in data processing are caused by poor mission planning. When you get an error in data processing, you think, damn, I'm doing something wrong with data processing. What am I doing? Well, about 2/3 of the time, look backwards. Look towards mission planning, because it's going to be caused by overlap issues or ground control point geometry issues or things like that, flight altitude issues. So poor mission planning causes all kinds of errors further down in the workflow. So that's why that's really the answer of the question in this. Why flight operations matters is because it causes errors everywhere. So for starters, one of the first things I said is asking, is this a good project for drone photogrammetry? Drone photogrammetry covers a huge number of projects, but is not good for absolutely everything. Good projects we consider typically are between 1/2 acre on the small side and 500 acres on the large side. 1/2 acre, smaller than 1/2 acre, might just be quicker to shoot everything you need on the ground. Bigger than 500 acres, probably more cost effective to actually hire a manned aircraft to cover that much ground. There are some intermediate areas. We've done projects up to about 1,000, 1,500 acres before that still makes sense by the drone, but above 500, you might want to consider adding manned aircraft into the option. Or up to about 20, 30 miles of linear missions as well, if you're doing pipeline corridors, railway corridors, road corridors, things like that. Up to 20 miles is very good for a drone. Beyond 20 miles, possible with a drone, kind of depends on your needs. Low to moderate vegetation is the ideal. Complete total dense tree cover. Nope, a drone cannot see through trees, so you're not going to be able to map under very dense vegetation. It is great for topo mapping. It is great as part of an ALTA survey. Of course, you can't do an entire ALTA survey with the drone, but a whole lot of it you can. It is great for extracting 2D and 3D planimetric features and for doing volume calculations for any earth-moving sites, mining sites, things like that. Cool, that's a lot of really great projects. But like I said, it's not everything. Very, very, very large projects, over 500 acres, over 40 miles, over 100,000 photos and processing. That's a red flag that you might want to consider a different technology. Dense vegetation and tree cover, nope, doesn't work, can't go through it. Extremely high accuracy tolerances. If you absolutely need to be able to measure your accuracy of 3/400ths or so, a drone is not going to get you 3 or 400ths of a foot of accuracy, no matter what a lot of the hardware manufacturers try and sell you. It can't do it. And there are some projects where you need it. You need your laser scanner, you need your total station. Drone's not going to be the right tool for that job, but most projects, a tenth is going to be good enough. And indoor and underneath overhangs, it's a question we get a lot. Can a drone photogrammetry map inside of a room? Kind of, but no is the real short answer. It is it's another one of those science fair things. It's technologically possible to fly a drone indoors and get enough pictures and map X, Y, and Z. But it is so incredibly complicated that there are always going to be cheaper and easier ways to map indoor or anything like underneath the underside of a bridge. Drone photogrammetry is going to be rarely the right choice. And of course, underneath trees too. You can't fly under the trees and still get good mapping data from a drone. All right, so next up on drone is safety and airspace restrictions, and that side of mission planning. And this is where we were talking about that question that came up about, what was that? About the Bay Area and where can you fly in the Bay Area? So for anyone that has their Part 107, this is one of the FAA's charts. Operations in Class G airspace are allowed without any permission, and classes B, C, D, and E airspace are only allowed with air traffic controlled permission. And if you look at this map, it's kind of intimidating because Class G, these tiny little pink things at the bottom, are the only things that you're allowed to fly in without permission. But it's also misleading because the vast majority of airspace is actually open. In fact, 99% of the United States by surface area is Class G airspace. Now, the problem is most of that 99% is what people often call flyover country that you don't actually need to survey. Many projects are going to be within populated and areas and controlled airspace like the Bay Area, but there are other options available. And in fact, here's kind of the real short answer is you can fly in all controlled airspace with the proper approvals. Now, we've gotten a ton of requests for these different types of approvals, and we've done all of the complicated ones. In fact, we have secured permission to fly on the airport property of controlled airspace. It takes a long time to be able to do it because you need to work with the tower, you need to work with the FAA. But the short answer is the closer you get to an airport center, the more paperwork there is. There's something called LANC. Yes, that is pronounced Lance according to the FAA because they get to choose how to pronounce their made-up words. And with Lance, you can get instantaneous authorization that already allows you to fly in a ton of Bay Area controlled airspace. There are a number of service providers out there, companies like Kitty Hawk and AirMap, both provide apps on your phone that allow you to request and get approved instantly for a huge chunk of airspace, even when it's controlled airspace that's in the Class B, C, D, and E airspace. But even that LANC has limitations. There are things that they'll call 0-foot floor areas where they say you cannot take off. And those areas you can fly in as well. You just need manual authorization. And this is where it starts to become more of a business decision rather than a technological one, because we have secured manual authorizations in extremely restricted airspace before, but some of them have taken us up to 90 days. So if it's a huge project and it's expensive and there aren't very many other options, then maybe it makes sense to go through the manual authorization process, something that our team and our flight operations team can actually help with because we are experienced with it. But a lot of times with manual authorization, you have to make the business decision of, okay, it's not worth that time to get it flown, to get it approved. Let's just send a crew out. Let's just do it on the ground. Kind of annoying, but like I said, we've done really strict ones all the way from on the surface of Class C airports. We've never done the surface of a Class B, but we've done very close to the approach patterns of Class B. But anyway, we've done federal prison penitentiaries before that are highly restricted airspace. It all can be overcome with the right paperwork right now. That's kind of how it works.
So Logan, is there a difference between the FAA airspace authorization and those DJI geofencing?
Great question. No, these are not the same thing. In fact, FAA authorizations and DJI geofencing are totally different ways of flight planning. So oftentimes the FAA says they have their map out there that says, here's where you can, here's where you can't fly. It's based on that controlled Class B, C, D, E airspace. Now that doesn't mean anything technologically. They can tell you not to and the drone will still arm itself. However, DJI, the, again, far and away most popular drone company, has put in geofencing on their systems that will prevent you from taking off within some controlled airspace. Now the problem is these maps aren't drawn the same. Some places the FAA says you can't fly and DJI will actually let you. Some places DJI will let you totally, or will not let you take off, and the FAA says you're actually fine to do here because of varying just rule differences, map changes. So it's worth noting that FAA is the legal authority to fly. DJI is kind of the technological authority to fly. Again, this is all overcomeable. There is no no-fly zone that's just strictly no flying. DJI, the no-fly zones are much easier to accomplish. They, again, have stricter procedures based on how restricted the airspace is. If you're 5 miles away from an airport, I'm kind of making these numbers up, but if you're 5 miles away from an airport, you just check a box that says, yeah, no, I'm flying here anyway, I have approval. If you're 3 miles, you might need to fill out some information, give them your name and phone number, and then say, yeah, I have approval. If it's one of those ones where it's on an airport property, you actually need to submit for a manual unlock where you say, yes, here is my proof of authorization to fly on this. Please unlock me for 3 days to fly on this property, and then they'll turn it on for you remotely. So that's that. Another thing that I just want to talk about real quick is on the FAA side, waivers and authorizations. Like I said, there's that LANC system, which grants instant authorizations and is available at most airports nowadays. There are the manual airspace authorizations that takes a lot more time, approved under many circumstances. We've gotten to that, but it does take time. And then there's something that's only a government bureaucracy could be this nitpicky. There is a very, very, very important distinction between a waiver and an authorization. An authorization is almost always going to be what you want. A waiver is a different process. If you ask for an airspace waiver, you are going to go down an infinite rabbit hole of miserable bureaucracy. If you ask for an airspace authorization, you might actually get it. But the waiver is a technical path that's honestly more meant for like when Boeing is test flying an unmanned prototype vehicle over half the state of Nevada or something. Like that's what those waivers are for. You need to hire a law firm to get you a waiver. So don't actually ask for one. What you really are looking for are airspace authorization. And again, questions on this is all legal stuff, and it's really only under, these are some of the more challenging ones, but we can help you with that. Having a flight operations team, someone that knows how to deal with that, can definitely help. So reach out to us if you have any questions on these. And the last thing on the kind of safety and legal side that I want to talk about is flying over people. Strictly letter of the law, you may not fly over other people unless they are participating in the operation of the aircraft, located under a covered structure, Employees are not considered to be participants, and people in moving vehicles are not considered covered. Okay, that's the letter of the law, but flying drones in the real world, honestly, the FAA, what they're actually looking for is bad actors, not minor infractions. If you fly a drone over a road in the real world, the FAA does not care. They are looking for terrorists. They are looking for people that endanger manned aircraft. If you are flying near, one of those ones that shut down that airport in London, yeah, you're going to get in trouble for that, but you're not going to get in any trouble for flying a drone over a road, typically, as long as you're being safe. That's really what they care about, is using your good judgment is something that really should be just kind of common sense across everything. Use your good judgment. If you think it's really unsafe, then don't do it. But there are many drones, at least with some of these rules, people don't follow them super, super strictly, and that's just considered okay. Don't be a bad actor. Don't be an idiot. If you're a bad actor and an idiot, you will get in trouble. But be safe, be responsible. That's kind of our general advice for flying drones in the real world. All right. Next thing that I want to talk about in mission planning is going to be choosing an autopilot software. So those of you that have flown drones, and even those of you that haven't, should probably be aware that for drone mapping and drone surveying purposes, you don't actually need to fly the drone. The drone flies itself. In fact, they're so easy these days that there are a lot of people that'll fly. They have their Part 107, they fly it, and they have no clue how to use the thumbsticks on the drone. And that's totally okay these days. Heck, the SenseFly EB, for a while, I don't know exactly what the latest models have in terms of their legal restrictions. They either don't have thumbstick for controls, or they had a little sticker on them at a time that says, if you so much as touch this thumbstick, it voids the warranty on the drone. Drones fly themselves. So what autopilot software should I use? Well, there are a ton of different options out here. And most autopilots, to be honest, are super similar. And in fact, from a data side, if you use them right, they're identical. We don't really care. So whether you use Map Pilot, Drone Deploy, DJI Pilot, DJI GSRTK, Litchi, Pix4D Capture, these are just some of the bigger ones. If you are comfortable with any one of them, keep using it. I would not try and encourage you to change because, quite frankly, they're all very similar. Use what fits with your workflow. If we had to make a recommendation, if you're totally new to it, for Phantom 4 Pros, the Map Pilot by Maps Made Easy, we think is the best overall. They all have their kind of quirks with them, but we think it's the best overall for Phantom 4 Pros. If you are flying the Phantom 4 RTK, the GSRTK app that actually comes with it is actually totally capable of doing everything. And again, for workflow reasons, we think it is the best option out there. Once again, I should point out, before anyone says, but this app sucks at this and this app sucks at this, I should probably acknowledge, yeah, every app has something that you can knock about it. None of these are perfect. None of these are complete magic bullets. These are just our recommendations at the best overall one. And if you do have a preferred app, great. Keep using it as long as you're getting good quality data out of it. One feature, though, that is quite useful with drones is terrain awareness with the drone autopilot. Not everything has terrain awareness. The two that I just recommended do have the ability to do that. Map Pilot by Maps Made Easy and the DJI built-in GSRTK app, both are capable of using terrain awareness, where the drone approximately matches the terrain. This really helps on larger projects, which we would consider in this case to be more than about 50 acres, where there is significant relief, maybe 200 feet or more. It's only available on some autopilots. It's a little bit tricky to use to make sure that the drone tracks the right surface model. It has a couple of little glitches too if you're working on active mining sites where elevation used to be up here and then they cut away half of the mountain and it's 100 feet lower or a couple hundred feet lower. That said, for very large projects, using the terrain awareness feature definitely can get you more consistent, more reliable data at the cost of a bit more of an advanced mission planning workflow. Why terrain awareness matters, though, what you see here is two exact photos. This is in the post-processing side. These screen caps are from Pix4D, where this drone was flown at a fixed altitude. And on the right-hand side, you see a point with a bunch of rays going through it that shows that that point on the ground can be seen from like 20 photos or something. Whereas on the left, you see a photo at higher altitude. The ground is so much closer to the cameras because the drone was flown at fixed altitude that you can only get a couple of photos can see a single point up there at the higher point. Now for this project, this was used as an example. I should point out that part of the project didn't matter. It wasn't part of the area of interest that they were surveying. The drone just happened to overfly it. I thought it would make a good example. However, if it did, you would be getting lower accuracy on that point that's higher up. So if you really cared about accurately mapping the upper part of that hill there, then you probably should have used terrain awareness or at least flown higher so that you get proper overlap on that higher area of the project. And another thing I should point out, this is one of those errors too when it comes to flight altitude, that there is really no way to fix it in post-processing. If you fly the drone and there's a part where there's a big old hill that gets so that the drone's actual altitude is only 50 feet above ground, there is nothing, no amount of post-processing magic that can solve some issues like that. Sometimes you can really work your magic. A good photogrammetrist can get some data out of it, depending on how severe the issue is. But this is why flight operations matters. Like just thinking about doing a quick look on Google Earth before you fly a project site to know what the general terrain looks like makes such a big difference because it can prevent these types of errors that would mean you have to refly the job site. All right, so next up on mission planning is talking about overlap and accuracy. These are going to be a lot of the settings that you have to put into the Autopilot software. So it's not something you need a PhD in, but you do need to have a basic familiarity of what type of overlap and flight altitude you need to set in order to get required accuracy. So the first thing when people say is, what accuracy should I fly? I say, start with your desired results, for what altitude you should fly. The biggest time killer that we see is, let's just see what we can get out of it, right? People that don't start with a goal in mind with their drone, they're like, I just want to get something out of it. Let's see. I like to compare that to, can you imagine sending a crew out to a job site with some tools and just see what they come back with? That's kind of the same thing. If you don't actually know what your desired results are, you're not going to get anything good out of it. So start with your desired results. Starting with your requirements for me means start with your accuracy. So here's our first table that has a little bit about the expected accuracy and the coverage that you can get. And what you will see pretty clearly in this table is that the lower you fly, lower altitude, you get better accuracy, 1/10 of a foot vertical, better than a 1/10 horizontal, but at the expense of you cover a lot less area. This table, I should point out, is optimized for the Phantom 4 Pro and Phantom 4 RTK series of drones. Fixed wings are different because fixed wings can't really fly low. They have to fly at 300 or 400 feet, but they can cover a heck of a lot more ground. But yeah, as you go up higher, at 200 feet, you can cover 20 acres per battery, but you'll get 2/10 vertical. And I say 2/10, in almost all cases, we exceed the accuracies that you're seeing on this table. We say 1/10 of a foot, usually 200 to 300 feet, you can still get a 1/10 of a foot accuracy in most cases. And then 400 feet altitude, you are giving it up. Usually we see about 2/10 vertical accuracy is average for a 400-foot altitude flight project, but you can cover way more ground. 50 acres is even a bit conservative. Sometimes you can get 60, 70 acres out of a single flight. So when you are doing 200-acre jobs, yeah, you're going to want to fly higher. And typically, that 2/10, 3/10 vertical is far more than enough by every measurement standard for 1-foot contours, and usually even good enough for 1/2-foot contours perfectly accurately. Now then, let's talk about types of flight patterns, because that matters too. On the left, you will see what are some of the most common flight patterns out there that the different apps offer. Manual flight, single grid, double grid, linear missions, and terrain awareness, which we've already covered a little bit of that. Single grid, also known scientifically as a boostrophodonics flight path, is that lawnmower style, just back and forth flight pattern. Covers up, down, or left, right, whatever, a single time, and then comes home. By contrary, there is a double grid mission, which does the same thing and then rotates at 90 degrees and flies it again. I should point out, we have done all kinds of testing on this, And when it comes to survey work for probably 98% of projects, a double grid provides no benefit whatsoever to accuracy, but takes a lot more field time, and it takes twice as many photos, which actually winds up taking 4 times as long in data processing. So a double grid pattern is very, very, very rarely going to be something that you want, to the point where we pretty much, we just say don't do it. The reason a double grid pattern actually exists, what the double grid is good for, is often when you're trying to create a 3D model of a site for the purposes of things like virtual reality or video game rendering. When you need to get 3D modeling on the facades of buildings and like get a little bit better coverage underneath eaves onto those facades, higher quality data of the windows and the sheer faces, that's what you need it for. The double grid does not provide a measurable improvement of accuracy when it comes to measuring topographic features. So if you're doing mapping, if you're doing contours, if you're doing a topo map, the double grid does not provide a benefit. It provides a visual benefit for 3D models where you care about those facades. But again, from a surveying perspective, it has significant costs in terms of times and data processing costs without really any corresponding benefit in terms of the final data that you get out of it.
Logan, we've got a question for you. Do obliques help?
That's a great question. I've got a slide coming up on that in just a second. No is the answer, but I'll go into more detail. Next up, another option is linear missions. Linear missions are exactly what they sound like. It's for when you are not flying a single, like a block or a polygon, you're flying a line. Very common for roadways, pipelines, train tracks, right-of-ways, all kinds of stuff like that. These are really useful. Again, the ones that we like with linear mission planning are the DJI GS RTK and that Map Pilot by Maps Made Easy. Both have really good linear mission planning capabilities. So that's pretty simple. It flies a couple parallel routes along a route. You always want at least 3 overlapping lines. Flying a single flight path on a line will not get you good data whatsoever. You need at least 3 to get really good quality data. And lastly, like I said, is terrain awareness. That's where if there's a lot of elevation changes, this image on the right shows you actually what some of the elevation changes in profile can look like for this particular linear mission. Really useful, but a bit more complex, good to have for your autopilot. Next up, let's talk about overlap a little bit. First off, so we talked about the mission plans, but once you select your mission, you still need to select what's the right overlap to fly. Now, there's front lap and side lap. This little graphic on the right shows you what overlap means. When you take 2 photos in a row, how much of them is the same from one photo to the next? And I should point out that there are very dramatically different requirements for traditional photogrammetry and modern digital drone photogrammetry. Traditional photogrammetry flew with much lower overlap than we do today. Something like 60-30, meaning 60% front overlap, 30% side overlap, was common in traditional aerial photogrammetry. But that's because they were flying with $1 million calibrated cameras. They used way more, they had way better sensors than we put on a drone. High quality, but very heavy, big, and expensive. And they also had way more ground control points per photo. Typically, they often had 1 or 2 control points per photo, whereas drones, you'll often take 1,000 photos and maybe only have 5 or 10 control points or something. So with modern digital drone photogrammetry, where you are getting, you're using a cheaper camera, a not $1 million metric camera, 75-75 overlap, that's 75% front, 75% side, is a very good sweet spot that we've found. It provides enough redundancy to create really high accuracy to account for normal everyday changes in elevation, radio glitches that cause it to skip a photo, memory card glitches that cause it to skip a couple of photos. It provides a really good kind of Goldilocks zone without just going totally overkill. That said, some projects do cause insufficient overlap. Here we have just an example of a project that was planned poorly where some of the overlap was just really, really low. If you look in the middle here, you have this area of a single flight line. That'll get bad data. And on the left, single flight line, bad data. And on the right, you actually have these areas that have, 4 or 5 different flight projects overlapping all at once, which is too much data, which is an issue. But anyway, that's overlap. Like I said, 75/75 is really a good sweet spot for overlap. Next up is the question about nadir versus oblique. So what is an oblique and what is a nadir image? Nadir, more or less, means straight down imagery. Oblique, you have your low obliques and high obliques there, as shown on the image to the right. And they can, technically, offer you better identification of vertical features. Again, they might be able to see the facade of a building a little bit better. However, it often comes at the cost of greater processing time and lower resolution. In fact, just as an exercise, if you look at the high oblique photos, look at the size of a square on that high oblique image versus the size of a square on vertical. Vertical, they're all approximately the same size, but the ones off towards the horizon of high oblique are really, really small. That actually lowers your overall resolution. You actually get worse quality data by flying oblique because there's much more effective distance between the camera and the ground. And we've done a whole bunch of testing on this, and the short answer is, again, for topographic surveying purposes, obliques add nothing. In fact, it often makes it worse. Now, again, that's not a universal statement for all drone flights. If you want a 3D model that you are importing into the video game that you're building, sure, use a ton of obliques, go for it. But that's not what we're doing. We're doing surveying. And from all of our testing, obliques add a lot of complexity and negligible and oftentimes like worse accuracy than straight nadir only. So summary of kind of our best practices in these flight planning things. Single lawnmower flight path saves you a lot of time, gets you good enough quality data. 75/75 overlap saves you a lot of time, gets you good enough quality data. And nadir only, no obliques, saves you time and gets you good enough quality data. I guess that's all related.
So while 75/75 is best practice, what type of site conditions would require a need for higher or lower overlap? So when would you deviate from 75/75?
Great question. I would never go lower. I would basically never set it anything lower than 75/75 personally. The situations where you would need it higher is situations where there is more vegetation. So if we're talking dense scrub brush, dense and fairly uniform vegetation. So dense scrub brushes, a lot of like vineyards can look like that very often, agricultural fields, grasslands where you've got a couple feet of grass over the vast majority of a project. In areas with a lot of uniform vegetation, increasing it to 80/80 or in some cases 85/85 can, but not always, get you better quality data.
Why does that help? So if you've got dense tree cover, why is bumping up the overlap effective?
Because it gives you it gives the software more options to find matches. It says, ooh, there's a rock, I see one, and it can find it in more photos, whereas that rock might actually be covered by some of the vegetation in different camera angles. It can find the same tree branch. It gives it more data. Now it comes at the huge expense of processing time. A lot more the more data that you add, it's a ton more processing time, a ton more field time, but it can result in better quality data. And this is where the last thing that I would say is there absolutely is such a thing as too much data. And this is, I feel it's one of the few things that really bugs me about a lot of the software manufacturers out there. The app manufacturers and like the photogrammetry softwares are all like, oh yeah, flight 85/85, double grid overlap, just throw it at the software, it'll take care of it. But that's because they don't have to pay for the computer. They don't have to wait. They don't have to pay for the pilots in the field. They don't have to pay for you to wait and watch your project process. So if it takes 1 hour to process or 12 hours to process, they don't care. Well, we do on the processing side. Time matters for you guys in the field, and time matters for everyone else in the office who's actually dealing with the data. If you double the amount of photos, it often quadruples the processing time in the office. So don't fall for the mistake of, let's just get more data. That'll fix problems. Almost never does more data fix problems that exist with flight planning. Good flight planning fixes the problem and getting the right amount of data. If you double the amount of garbage data you get, it's still garbage data. So don't fall for the trap of just like throw more at it, unless you have an unlimited budget, in which case please call us. But yeah, solutions are typically fly higher. 200 feet is often, 200 to 300 feet is really the Goldilocks zone for the vast majority of drone projects. Single lawnmower, not crosshatch, not double grid 3D. And don't go overlap overkill. If anyone sets something to 95% overlap, we legitimately throw away 80% of the photos before we even start processing if someone goes with overlap overkill. All right, so that was overlap and altitude. Let's move on to planning your ground control points, another pretty critical part of drone mission planning.
And Logan, I was actually holding this question, but it looks like this might be the right time. We had a question about how many GCPs can you get away with the Phantom 4 RTK using that DJI base station? In this example, It's a 5-acre site. They're asking if 3 GCPs would work.
I can tell you right now, yes, 3 GCPs would work for that with the Phantom 4 RTK, and we'll cover that. So first, let's start with a slide on non-RTK, because that's going to be the most common, and then we will kind of step up into some of the recommendations and workflows for the Phantom 4 RTK. And I should point out, when I'm using RTK, PPK kind of interchangeably here, because if you process the GNSS data, if you process the RTK, PPK right, then it does not matter whether you use RTK, PPK, DJI, Leica, SenseFly, whatever the heck you do it. Now that's a big if, that if you process the data right, but it doesn't matter. So this is all for starters for non-RTK. So now rule of thumb for GCPs non-RTK to start is 5 targets per flight battery. If your project site is big enough that it takes 2 batteries, you need 10 ground control. If it only takes 1, you can get away with 5. On the right-hand side here, we have a fairly small, fairly standard, just kind of part of a city block with 5 ground control points, which are those blue crosses, and a single lawnmower flight pattern at 75-75 overlap. And that is great quality data. With RTK, we said one target every time you move the base station. That's actually probably a little outdated. With more advanced workflows, you don't really need that anymore. But with non-RTK, you do need to set them in the corners of the project, plus 1 in the middle, and make sure that you fly a little bit outside of them. They need to be visible from all angles as well, so that you can't set one. Don't set it completely up against the edge of a building. Don't set it underneath an overhang or an eave or anything like that. So that's just kind of standard non-RTK Phantom style. This is, again, another chart that shows you how the accuracy spec is determined by ground control. So it's similar to that previous chart where you can see that at 100 acres, you can cover 5 acres, or 100 feet altitude, you can cover 5 acres per battery, about. And at 400 feet, you can cover 50 per battery. But how ground control plays into that is when you're flying higher, you need a lot fewer control points per acre. So let's say hypothetically you were doing a 200-acre site. If you flew that at 400 feet, then that means you're going to be using 4 flight batteries. And 4 flight batteries means that you need 20 targets, 20 ground control points total. Okay, that's not bad. Now, let's say you were flying that same project at 100 feet altitude, 200 acres. Well, now you actually need, that would be 40 flight batteries, and you would need 200 targets instead of 20. And setting and marking 200 targets is going to eat up a heck of a lot more field time. Not only that, boy, you're going to have a rough day processing that many photos. That is just bad. That's the definition of too much data. So that's where the targets kind of the bigger the site, you actually do want to fly higher. It saves you time to set fewer targets in the field and still gets you really good accuracy. Again, these numbers on here are very conservative. That 4-foot vertical or 4/10 vertical accuracy, we usually get better than that. Larger the project, the more GCPs you need. Here's an example of a project on the left is just a larger, probably 100-acre site or so. It takes 2 flight batteries, so it has, 10-ish control points. On the corners, you fly outside of them, there you go. The one on the right is a linear mission plan with 5 flight lines, 5 more or less parallel flight lines, and setting pairs of GCPs. I think that one has pairs set every 300 or 400 feet. I'll go in a second. I have some slides on linear missions in particular and how many control points to set on that. It's this slide actually. Corridor GCP placement. So we've done a lot of testing with where and how to set control points with corridors. And again, right now we're still, to be clear, in the non-RTK version because that is still the most common drone out there, just for anyone that's been flying drones for a couple of years. Non-RTK is the most common, so we'll get to RTK in a second. But generally what we've seen is an absolute maximum of 1,000 feet between GCPs if you want a 1/10 of a foot vertical accuracy. You want to be safe, go 700 feet between them. Zigzag pattern is what we generally recommend. But with the ends of the mission, do pairs. So you actually have 2 GCPs at the end, then zigzag every 500 to 1,000 feet, and then another pair at the opposite end of your corridor project. Pairs also can improve redundancy. If it's easy to shoot a couple extra control points, shoot a couple extra control points. We've actually tested this before. We've tested this over a 10-mile corridor where we actually set pairs of control every 200 feet purely for a test, and then said, okay, well, can we get good accuracy with control every 200 feet, every 400 feet? Can we do it with a single line? Can we do it with zigzag and pairs? And the end result is that zigzag is going to be the most efficient pattern. Switching from zigzag to pairs does not meaningfully increase accuracy. However, doing a single line of GCPs just down the center line of a road, for example, that does get you worse data. So don't set GCPs in a line because it kind of twists. If you'd imagine the way that GCPs kind of anchor a project, it can kind of twist like on a tightrope. So that we don't like linear GCPs. Zigzag GCPs are far superior to get the highest quality data for linear missions, at least.
And speaking of quality data, actually going back to, I think, a previous slide, how is the accuracy on pavement?
Great question. So accuracy on pavement is going to be better than the accuracy on dirt, which is going to be better than the accuracy in vegetated areas. So in fact, we've seen accuracy as good as 7/100ths of a foot on hardscape with drones, just with the Phantom 4 Pro, actually, with that test that we did. Where we had a surveyor with a total station set, 50 or 100 checkpoints, actually independent check shots on hardscape, and the RMFE accuracy was 7/100ths of a foot vertical. Super, super tight. On dirt, that's kind of why you're looking at more 1 to 2/10ths of a foot error on dirt. And on vegetated, it kind of, the real answer is it depends on what type of vegetation it is. Drones map what they can see. So if it's perfectly uniform, 6 inches of grass across an entire field, it's actually going to map the top of the grass. However, and this is something that I'm going to address a lot more in my second talk today about post-processing, for vegetated areas, even grass that looks fairly uniform to the naked eye is not for a drone or for a good photogrammetrist. There's a lot of variation. There's patches of dirt. Patches of dirt is great because that's raw surface that you can see. So a good photogrammetrist and a good line work drafter will make sure to focus on the dirt patches, on the low areas, to create a tin surface that is actually representative of the dirt surface and not representative of the grass. But that's something that's really addressed in post-processing. And again, typically you're getting that 1 to 2/10ths, but hardscape is almost always going to be slightly better accuracy than anything dirt or vegetated. All right. So next, moving on to RTK and PPK data. So RTK reduces the need for GCPs and checkpoints, but, and I cannot stress this enough, control and check data is absolutely still required for surveyors. And that's because of a couple of reasons, but the main reason is RTK and PPK data does not tell you where the ground is, it tells you where the drone was. And you don't actually care where the drone was, you care about where the ground is. So it is necessary. How many GCPs do you need for RTK to use them? Well, no control is not good enough. because you need control to properly calibrate your camera. Like I said before, these are not metrically calibrated cameras. The Phantom 4 RTK is better than most of the other ones, but we still see noise, and that can add about half a foot to a foot of inconsistency in the vertical direction if you're trying to use no control versus control, and that's assuming you get everything right. But that's another thing. You don't have any way to detect if there are any errors if you don't have any control or check data. And also, you can't localize your project. If you're doing something in absolute pure by-the-book MAT 83, great, you theoretically could. Well, you still need your control to calibrate your camera and detect errors. But a lot of projects, you need to localize around a single point. You need to localize around your base. You have control, you can translate and shift everything to actually get it to match up properly. So what our recommendation is for RTK is a minimum of 3 per project. Theoretically, you can get away with 1. We really like seeing 3 per project, and plus another 1 control per flight battery where practical. You actually really can get away with less. We've done 100-acre or 1,000-acre sites with like 10, 15 control points. Data checked out, they sent independent check shots, we got good data out of it. Usually I like seeing a little bit more just because it adds some redundancy in case some other error comes up. But typically, to be able to do this, I should point out, you got to know what you're doing with RTK PPK processing. This is not one of those just black box, like fly the drone and ta-da, everything magically pops out of the computer. You kind of need to know what you're doing, because if you mess up some of the RTK and PPK stuff, it gets tricky. But I'll actually talk a little bit more later today about integrating RTK and PPK data into your photogrammetry workflow and how you get good data out of that.
Look, I've got a question about camera calibration. How does Aerotas calibrate the camera on a DJI Phantom 4 RTK drone?
Repeatedly with every single project. So historically, cameras were calibrated in a lab that you would actually bring the camera in, take a photo of these grid lines and points, mark your fiducial points, and get the perfect camera calibration out of it. And then you would send that camera out in the field and everything would work magically and according to your camera calibration specifications. But with modern digital drone photogrammetry, the camera is actually calibrated on every single flight that you do, but on the software side, the photogrammetry processing side. And that's part of why we actually have so much higher overlap than traditional modern photogrammetry. When we fly at 75-75 overlap, a single point on the ground theoretically should be viewed by 4 photos going horizontally and 4 photos going, or 4 photos northing, 4 photos easting, and 4 by 4, 16 multiplied, you have 16 photos. So in a perfect flat world, a single point on the ground is visible by 16 photos. Now we can compare that across all of the tens of millions of points that are matched throughout this photogrammetry project to actually recalibrate each camera individually and make sure that it's tight for that specific project. So we do not calibrate these cameras in lab. In fact, that's not necessary, because we can effectively use the data that comes from the drone in the field. We use the photos to calibrate the cameras themselves on every single project. Now, this is another one of those things of why actually having a photogrammetrist do your data is kind of a good thing, is because that's a step where it's very possible to mess it up, or to have Pix4D say, hey, everything looks great. And a photogrammetrist looks at it and goes, no, that makes no sense whatsoever. But the software will attempt to do it by itself. Sometimes it requires a little bit of massaging from a photogrammetrist. But I hope that answers your question, that we calibrate the camera every single time a new project comes in. And in fact, another just kind of thing to note with that, these cameras are not super high quality, and they're also field equipment. They get beat up. And that's actually okay, but like all survey gear, it gets put in a case, that case gets tossed into the truck, it gets kicked, it gets dropped. And sometimes that knocks and modifies the calibration of the camera. So all the more reason why you actually need to, even if you had a laboratory grade camera calibration measurement tool, it wouldn't really work in the real world, because your drone would get kicked and it would get knocked out of calibration really, really quickly. All right. Next up, I want to spend a minute or so talking about some advanced workflows in mission planning, notably larger projects. So we've talked a lot about, these, okay, here's 5, 10, 20 acres, and that's great. In fact, that's most surveyors' bread and butter. There's so many smaller projects that are done. That's a good thing. We love small projects. They're much more straightforward. They're much more easy. But a lot of times, the real money for you guys is going to be in these huge projects. So what is a large project to us? Large project really is any time you need multiple takeoff locations. So for us, that typically means a project that is greater than 100 acres, or really greater than 50 acres, probably should be considered large, or longer than 1 linear mile. And the reason is you actually have to move the drone. You have to fly a couple of batteries worth, pick it up, put it in your truck, drive down to another takeoff location, fly some more, and then rinse and repeat. Why do you have to do that? Well, for starters, there's the legal rule that you need to maintain visual line of sight of the drone. I have a slide on that in a second, but you can't see if the drone flies 2 miles away. There's also the issue of the controller radio link. Real world conditions, the drone's video and radio control from the controller and the base station to the drone is good. It starts to deteriorate in urban areas. It'll start to deteriorate at about 1,000, 1,500 feet. In more rural areas, you might get as much as a mile, and then it's still going to start to deteriorate from there. But also terrain changes. If it's very, very hilly, very mountainous terrain, a lot of times you need to take off from different locations. So let's start with long corridor missions as well, because that's a much more common one. So 1,500 feet, if you're standing somewhere, 1,500 feet is about the limit that you can see a small drone like a Phantom. Or less if you're like me and you have absolutely horrible eyesight and need to wear thick glasses like this because I have terrible eyesight. 2,500 feet is how far you can see it if you have very good eyes and want to push your limits. For larger drones, you can see them a little bit farther, but you're never going to be able to see a drone that is a mile away. Anyone that's flown that far knows that it just disappears and it's just a speck. So what does that mean? If you can fly 2,500 feet that way and still see it, 2,500 feet that way and still see it, then you put that together, you're just shy of a mile that you can do from a single takeoff point. So for long corridor missions, oftentimes you take off, fly a mile chunk, drive a mile down, fly another mile chunk. That's kind of the way to do it with long corridor missions. So when you're doing that mission planning beforehand, when you're just setting up the flight in the Autopilot app, just plan it about a mile before you need to fly over and start another chunk. As far as the overlap, it's really important to ensure that the flight segments have some overlap. This is just to make sure that when you are flying those linear missions, if you accidentally left a gap of 100 feet where the drone didn't fly and didn't have any photos, that really sucks because, again, that's one of those mistakes that requires a revisit. You need to go back out. You need to fly data. So making sure that your flight segments do have some overlap, and where practical, try and put your ground control point in that area of overlap. That really ensures that both of those data sets, the drone flights that will be flown, I mean, if you're moving, it's going to be under different lighting conditions. It's going to be an hour later in the day. The shadows will have moved. The lighting may have moved. Heck, a truck could have driven by and covered the area with dirt, so the colors all moved. Maybe you flew it on a different day. Having that ground control point in there really helps. It is recommended, if you have RTK, to have that ground control point between them. Not necessary, because the RTK data should be able to adjust for that, usually does. But it's absolutely required if you don't have RTK. You need to make sure you have that ground control point in the overlap area. And that applies for large, huge block chunk projects, rectangular polygon missions, as well as linear on that one. As far as maintaining distance from the operator, like I said, 1,500 feet, 2,500 feet is about your limit. But I should point out, it's perfectly okay to move takeoff locations. That shouldn't sound intimidating. It shouldn't be scary. In fact, most of these autopilot programs are very simple to take out a battery, go restart a mission, start the next side of your mission, blah, blah, blah. When you're doing it, we always say try and take off from high points where possible. That'll help you out in terms of seeing the drone, as well as making sure that you're not going to hit any trees or power lines or anything that's above you. And it also gives you a little bit better radio reception for your controller and video stream. So yeah, we already talked about this. GCP placement considerations, where you can set it in the overlap areas. And then the last thing is processing large projects. Again, I will cover this a lot more in my later session today, But as with a lot of things I've said, an ounce of prevention is worth a pound of cure, right? Mission planning matters a lot. Don't try and collect too much data. Less data is often better for mission planning. Make sure that you don't make the mistakes that would require a field revisit, because those are the ones that really kill time. But then even with this, a lot of times you will have so many photos that you can't process it on a single block. I will cover that in depth in the post-processing, but just being aware that sometimes, yeah, you still need to break it up into 2, 3, 4, 10, 20 chunks for enormous projects when processing all of it. So I'll talk about that later and how to bring it all back together. Okay, we're approaching the end of things. But next up, let's talk about the field data collection side of flight operations. Field data collection is pretty easy from a drone standpoint, but first we want to start with collecting the data that the drone can't. I've mentioned before, drone can't do everything. Typically, if you're ever doing boundary work, you need to do that on the ground, usually for legal reasons. Even if the drone could see a monument, and no, it can't see underground yet, boundary work is going to need to be done on the ground. Building corners usually are obscured by vegetation or eaves. Depending on the level of accuracy that you need for those building corners, you may need to shoot those on the ground. Things like monuments, I put ADA compliant issues on there as well. Wheelchair ramps to get the right level of accuracy often needs to be done on the ground with the total station because it needs, 300th accuracy or whatever. Obscured areas underneath trees, and like I said, any of those ultra high accuracy points. But the vast majority of data, topo data, utilities, paint striping, all of that is going to be done by drone, and that will be the best way to do it. Next up is when we're talking about the field, you do need to set and mark your ground control point. We've talked about the number of ground control points, but not yet how to actually mark them. So for starters, there are a couple of things that set bad ground control points. Things like just a plain white square, this perfect center of that isn't really visible. That can add a tenth or two of error. Setting a corner of concrete is kind of tricky. Anything on curbs or anything on corners is hard for photogrammetrists to identify. Chevrons, we've mentioned before, we actually hate chevrons because surveyors all mark them differently. Some surveyors mark the outside tip, some mark the inside corner, some mark the center of the chevron between the outside tip and the inside corner. Just wildly inconsistent, and that leads to errors. Especially, we've seen a job where there were two survey crews shooting the control on different sides, and one survey crew shot the outside tip of the chevron, and the other survey crew shot the inside corner of the chevron, and that leads to, not catastrophic errors, but you're talking about, a couple tenths here, a couple tenths there. I mean, it really starts to make for a messy project when you add those sort of mistakes in there. Or this is always my favorite one that, aim for center mass. That's a great control point right there. But overall, the thing that we like the most, not things like that, just plain checkerboard targets. We actually make some here. They are, the ones that we make are biodegradable cardstock so that you can just stick a nail through them, leave it there, and on other sites. But the pink and green color that we prefer is just visible from space practically with the colors. No, you don't have to use our ground control points at all. In fact, any checkerboard pattern is really good. Black and white is fine. Black and white made the most sense in the era of photogrammetry where the photos were in black and white. But in the era of colors, bright pink and green that hurts your eyes, it's so bright, is much easier to spot from an aerial photograph.
Speaking of spotting it, Logan, how big is that target you showed?
Yeah, these ones are 16 by 16 inches is a really good medium ground for portability. You can carry it, and you can also very, very easily spot a 16 by 16 inch target from 400 feet, which is the highest you will practically speaking be flying. You can actually see it from much higher than that. We see people set 2 foot by 2 foot targets. Sure, that's great. They're easy to see. Heck, we've seen people set 6 foot by 6 foot targets, typical for traditional aerial photogrammetrists, for a drone project. That's absolutely overkill. It's not really a problem, but it's just a lot of data, or a lot to set targets that big. So 16 by 16 we've found is big enough to be seen at 400 feet and easy enough to be carried. Anything smaller, 12 by 12 kitchen tiles work, but are really, really, really tricky to see from 400 feet. 16 by 16 is easy to see from 400 feet, but yeah, that's kind of the best side of that.
Follow-up, what are your thoughts on visual ID points like manhole covers, signpost, the end of a parking stripe, the spike of the guy wire?
Yeah, those are good as a last resort. They are usable if absolutely necessary, but typically they're really tricky because for a photogrammetrist, especially one that hasn't been on the site, when you say, oh, it's the end of the parking stripe, there might be 100 parking stripes or more in a parking lot. Which one do you mark? You have no clue. Manhole cover, again, identifying the exact center is kind of tricky from the air. And like I said, you're going to get close, but it adds like 1/10 of a foot of error, which for most projects, if you make everything off by 1/10, that really sucks. So we don't like visual ID points. Targets are very much recommended. If you're working on dirt, definitely set a target like this. If you're working on hardscape or asphalt, paint a target wherever possible, or use one of these and just stick a short nail through the center of it into the asphalt, something like that. But targets are pretty much always going to be recommended over visual ID points. Another thing about flying, once you mark your targets, collect your field data, we really recommend using checklists. This is our checklist that we provide. If you want one, let us know. We'll send you one free of charge. We send these checklists out to everyone just because it's good practice. Checklists are great. Simpler is better. And the reason that we like checklists is not to say, you don't know what you're doing, use this checklist. It's to avoid dumb mistakes. Anyone that's been in surveying or really any field long enough has made some sort of stupid mistake that they've left something in the office when they drive out to a job site, and it's cost them 4 hours. They have to drive back. They have to do this. You have to do this because they forgot the dumbest little thing. In fact, our checklist here, if you can read it on the right, the packing checklist is actually my favorite part because I am personally prone to making those dumb mistakes where I forget to put the batteries in, I forget to put the iPad or the memory card. Those are the ones that I just hate myself if I lose a couple hours of a day. But if I use a checklist, it helps it. So they just make your drone operation so much more reliable because you can just say, hey, follow the checklist. And if you're worried, oh, do I have everything? Well, did I follow the checklist? Yep, great, good to go. And that's how you just keep everything super reliable. So we keep the checklist in the box. Whenever I do drone flying, I use it every single time, even though I've been flying a drone for 6 years at this point.
Hey, Logan, backing up a step, we've got a question about mission planning. Do you see any increase in accuracy when flying a road, flying it parallel versus perpendicular to the road?
Great question. No meaningful increase of accuracy. There is, however, going to be usually a meaningful difference in flight time. If you fly perpendicular to the flight, where you zigzag left, right, left, right, left, right, and slowly go up a linear mission, that will take a lot longer because the drone has to stop, turn around, make a corner, turn around, go back and forth. So you actually cover a lot less distance that way than you would by flying parallel to the road. The other thing is also the safety and legal consideration is that technically if we're following those rules of, don't fly over people, flying parallel to the road is great because you can fly on one side of the road, cross it once, and fly along the other side and do that a couple of times on one side or the other of the road. If you zigzag it, you're crossing it a lot more. Now, it's not irresponsible, I would call it, but it's just, mission planning wise, we generally recommend flying parallel. That said, I mentioned that there are no accuracy harm from doing that. If you want to fly perpendicular to the road, that for whatever reason that makes sense for your mission planning, by all means, do it, go for it. No problem whatsoever as far as accuracy goes. It's purely a kind of operations preference, not an accuracy preference there.
But your recommendation would be to orient lengthwise down the corridor?
Correct. Lengthwise, parallel to the corridor. So yeah, jumping back into our field workflow, what a typical field workflow looks like is you're going to start by once you get your drone, you finish your packing checklist, you go out to the office, you're going to start with checking for site restrictions like airspace, making sure it's not in a controlled zone. You want to check for TFRs, temporary flight restrictions. All of the many of the autopilot planning apps have these in there now. These are things like wildfire notifications. Those of us here in California, are dealing with obviously a boatload of fires right now, and that's really awful. But one of the things that can make it worse is getting in the way of firefighting aircraft. Firefighting aircraft have like absolute complete supremacy, and that's one of those things that actually, if you do fly a drone near a wildfire, they will try and find you and arrest you for that. Like, if you cross over a road, that no one cares. Nobody cares about that. But if you fly a drone near a wildfire, you're in a heap of trouble. So do not check for fires right now, I should say. Like I said, those apps, AirMap and Kitty Hawk, both provide that sort of data. But check for fires. Please avoid the fire flight restrictions and let the firefighters do their work there. Checking your weather forecast, making sure there's no rain, creating and saving your flight plans in the office gets done. Go through your equipment packing checklist and then head out to the field. From there, set up your ground equipment, your base station, do a quick inspection of your aircraft, survey your ground data, your GCPs, checkpoints, and then load your mission and click go. And you'll notice through all of this with flight planning, I haven't talked about here's how to fly the sticks, here's how to pilot a drone, here's how to blah, blah, blah. That's because, like I've said a handful of times, the drone just flies itself. The autopilots are so great right now. You just click go, and when it comes back, just verify, make sure that it took the photos you wanted it to, and you're great. 15 minutes of just watching a drone buzz above you. It's boring, it's a tool, it's spectacular. I will pause for a second because that actually concludes kind of the meat of what flight operations is. I'll briefly go over what the office workflow looks like, but again, I will cover that in depth in my next session. But I will pause for a second and see, Trey, are there any other questions that, that anyone has had? Or if you're thinking of one, feel free to start typing it in, and I'll give one more opportunity for questions before signing off.
Yeah, no open questions at the moment. You know, you mentioned that when you're letting the autopilot do all the work, how do you verify that it's collecting the images correctly? I mean, if you've got a big project, is there a way to check that while it's in flight? Should you check before you leave? What are some good best practices there?
Yeah, great question. Good best practice for that is just keep an eye on the controller, on the tablet, while the drone's flying. All modern autopilots, they drop little breadcrumbs. You can see a little shutter flash as it's taking an individual picture. And if you just keep basic monitoring of the drone and the controller, any problem will become apparent absolutely immediately. And I say problem, that's not a scary thing like, oh no, the drone fell out of the sky. That basically never happens. But problems are often in regards to radio control, that the radio link dropped for a second. Or the ones that are real, like just you want to kick yourself, you leave the lens cap on. And so it takes 300, 400, 500 photos of the drone's lens cap. That's a real frustrating one if you put a lens cap on your camera and then don't take it off. And just a simple, that's why I like those checklists too, right? The remove lens cap is on the checklist, and heck, I would have fallen for that a number of times without those checklists. But basic monitoring of the heads-up display on any of these autopilots is plenty. What you don't want to do is set it in the back of your truck and go walk away, come back 10 minutes later. That's not good practice. That's also not illegal, or not legal. Part 107, you need to keep your eyes on the drone and everything. But yeah, just keep a basic monitoring of it, and you'll get good data.
And we do have a question about line of sight, as you were talking about monitoring the drone. Could you talk about line of sight real quick? Yeah.
So the FAA's laws are, line of sight just means you need to be able to see the drone visually with your eyes, unaided by anything other than corrective lenses or glasses. So what that means is if you're using glasses or contact lenses and you can see the drone, you're good. If you're using binoculars, a telescope, or some sort of digital transmission signal to see the drone, that does not qualify. The FAA has not put a specific law on how far qualifies as visual line of sight. There are some people that really push the limits out there. I've seen some crazy YouTube videos. Some of you might see in the crazy YouTube videos of people that put like big, giant, brightly colored flags or strobe lights or other things to be able to extend what visual line of sight is. Even those, usually it's like, okay, instead of 1,500 or 2,500 feet, maybe it's 3,500 or 4,500, but at the cost of a very expensive and potentially dangerous workflow. Don't tie stuff to your drone. If you try to tie flags, there's a good chance that something like that will then get sucked into the propellers and cause a crash. So, so visual line of sight, the distance is not defined by the FAA. However, the ability to see it without binoculars or telescopes or anything like that, that is what the definition is.
Thank you. And then I got a question here about how expensive are those GPS-capable drones, maybe the Phantom 4 RTK?
Yeah, great question. So the Phantom 4 RTK, depending on how many accessories you get, typically runs around $10,000 to $12,000 for the Phantom 4 RTK. And again, I know for anyone that's going out there and hunting and nickeling and diming, yes, there's absolutely cheaper options out there. If you want to buy just the drone and not the base station, or you only want one battery, or you only want this and that. Realistically, if you want just kind of the business advice, expect to pay $12,000 for everything you need, and you're going to be in good shape for those. It can go up from there. Like I said, the M210 V2 RTK and the M300 series RTK, those are much more than that in the $20,000 to $30,000 ranges, plus whatever you want to spend on cameras with one of those. But again, our recommendation is the Phantom 4 RTK, which is the cheapest at 12 grand. It's actually the cheapest of the RTK options available that'll get you there. And we think it's the most reliable and our favorite of the options out there.
And then backing up a quick second, you had mentioned pilot in command. Could you elaborate on what the pilot in command is and how they must be licensed?
Yeah, so that is, I probably should have had a slide here about the legal side of things, which is the FAA has a set of rules called Part 107. Part 107 is the requirement that a pilot must have in order to fly it, in order to fly a drone. It's a fairly simple, you need to study for it, but it's a simple test that you sign up for with the FAA. You have to take it at a test center by an airport, although I haven't taken it since COVID times. I don't know if it's still in person or if they've found a digital way to do it. But it's basically a test that gets you a license. You get a little pilot's license card that says you are certified to fly. And that means the pilot in command is basically the person that's been responsible for the mission. They're going to be the one that's in the field, holding the controls or supervising the mission, and they're the ones that actually are taking responsibility for it.
Gotcha. And I've got another question here. I've noticed when continuing a mission after landing to exchange batteries, it appears the drone is not taking photos. The number of photos does not increase on the controller, and the screen doesn't, quote, shutter. But if you wait long enough, the numbers will increase rapidly to almost catch up. It appears the controller was taking photos, but it was not properly recording the photos. I'm curious if Aerotas has noticed this as well.
That particular issue is going to be a software-specific issue that is very likely related to your specific hardware and software setup. So depending on what sort of iPad or tablet or phone you are using, that sound, I'm not familiar with that specifically because I'd need a little bit more information to diagnose it. And quite frankly, that's where some of our flight ops specialists would actually probably know more than me, depending on which app you're using. That sounds like it may be a processing bug on your controller side where the data's coming in, but the computer has kind of been overloaded. We actually see that and similar errors a lot when people are using just a personal cell phone and it's got a bunch of apps running in the background, it's got text messages and emails coming in, and it's a hot day and it overheats and it throttles the processor, whatever, things like that. That can definitely happen. However, like I said, without knowing more, it's hard to say exactly what it is, but yeah, that does sound like something that's fairly common. A typical solution to that would be maybe buy a new iPad, actually. I don't know if that's the answer that you want to hear, or clean up your software to make sure that you have no other parallel softwares running in the background. But it might, the real full answer might even be more technical than that.
So Logan, I'm going to give you your 5-minute warning here, running out of time, kind of along the same lines as that question. I've had a lot of folks ask me about SD cards. Now, those definitely have an end of their effective life, but what kind of problems could happen if you have a bad SD card? Yeah,
so this is one that most people think that SD cards, you buy them once and they're good forever. But like a lot of things, just like a battery after you cycle it a couple hundred times, SD cards start to have errors after you use them a bunch and cycle them and have a bunch of read and write cycles on them. So we actually see other kind of glitches if you have a very old SD memory card in the drone. And when I say old, I mean probably 2-3 years. Sometimes it can be shorter than that, but definitely at the 2-3 year mark. They just start to write, they skip photos is one of the things that you see a lot. Drone takes a photo and it doesn't actually write it to the drone. It misses it. Or sometimes it misses a few in a row. In very rare occasions, you take it back and it wrote nothing at all to the SD card because there was an error on it. That's pretty rare. Usually it's more, it tries to write one photo and it just, because it's experiencing errors, it takes longer to write it, so much time. So SD cards, the latest, you know, you should be spending on the order of $15 to $20 for a single SD card that is probably good enough for drone processing. But yeah, that's an important part of it because that's where all your data goes. All right, I'm going to take just the last couple of minutes here to just give you a brief intro to the office workflow. We talked about this before a little bit, but the office workflow is photogrammetry, line work, and then CAD finishing. Because for us, the point of a drone getting to that top of the drone surveying journey is about getting your line work and getting everything into CAD, not just about getting a pretty picture. That's where we're going to get that integrated workflow with final survey deliverables and actually getting everything on a map. And that means photogrammetry, where you stitch your photos into the interim files. You take all those hundreds or thousands of photos that you took, put them together into a nice 3D model. That creates a point cloud, orthophoto, digital surface model. Reduce it to a CAD-friendly surface, get your topo points, your tins, extract your polylines, extract your features. There you go. And then finish it in CAD. Merge in your field shots, draw your contours, create your tin surface, apply your layers, your symbology, your annotations, things like that. So once again, the office workflow photogrammetry goes through to line work drafting, goes through to CAD finishing to get you that final product. And that's what I'm talking about later this afternoon, starting in just about half an hour.
And Logan,
but again, the point of the final workflow, of the office workflow, and the field ops that we all talked about today is to save time and money. If you're not saving time and money, then you're not doing it right. You're doing a science fair project. Drone programs should not be science fair projects. They should be businesses. Pick the right tool for the job, make a business out of this, utilize a complete workflow, and that'll get you there. And 2 minutes of plugs, that's what we do. Aerotas provides drone data processing for surveyors. We do the photogrammetry, the drafting, the CAD finishing to actually get you a CAD file with all the data that you need, none of the data that you don't, high quality, super accurate, super reliable data. If you want more, you can book a meeting with us live at aerotas.com/book to book a live meeting with us through this conference app and everything. Or I think there are ways to do it on the conference app as well.
And before we run out of time, another question for you. What is the update rate RTK on the drone?
I'm assuming the rate at which it gathers GPS data, and the answer is 5 hertz. It actually gathers a GPS observation every 0.2 of a second or 5 times a second, which for those that work with GPS data knows that's a ton of data, but also the drone's moving very fast. So gathering that high fidelity data at 5 hertz or a GPS signal every 0.2 seconds is really, really great. That's what it does.
And for those of you who might have noticed, these slides are a bit different than what was available for download. So as Logan has up here, you can definitely get the updated presentation from him, Logan at aerotas.com, and he'll make sure you get the most up-to-date presentation.
And with that, thank you all so much. I hope to virtually see everyone again at my next presentation in half an hour, where we get to go through all of the fun stuff of photogrammetry, and I get to show you how the mistakes that you might have made in flight ops present themselves in photogrammetry. Thank you all so very much for joining. I appreciate it. Like I said, shoot me an email and let us know, or book a meeting if you have any other questions.